Look up at the night sky and tell me what you see, because I can promise you that your eyes are deceiving you at this very moment. Every star, every planet, and every single atom in your body represents a tiny, insignificant fraction of what is actually out there in the cold dark. For nearly a century, astronomers have stared into the abyss, believing we were looking at the entirety of reality, but the numbers suggest we are blind. There is a shadow universe pressing against our own, a ghost that walks through walls and flows through your veins right now without leaving a trace. We call it dark matter, but that is just a comforting label we slapped on a cosmic monster we do not understand and cannot even see. Imagine walking into a room and realizing that 80% of the furniture is invisible, yet you keep bumping into it in the dark. That is the state of modern astrophysics, because the universe is heavy, far heavier than it has any right to be based on visible light. The gravity holding our galaxy together is too strong, suggesting there is an invisible hand gripping the Milky Way, refusing to let the stars fly apart. If you removed this invisible substance, our sun would be flung out into the intergalactic void, condemning Earth to a frozen, eternal solitude. We are trapped inside a gravitational cage made of a material that refuses to interact with light, radio waves, or any sensor we have ever built. This is not just a scientific curiosity. It is an existential crisis that implies we are the anomaly in a universe made of shadows. The story begins with a crime scene investigation on a galactic scale, where the laws of physics appear to have been broken by an unknown perpetrator. In the 1930s, Fritz Zwicky looked at the Coma cluster and realized the galaxies were moving fast, too fast to stay grouped together. By all calculations of standard physics, those galaxies should have scattered like marbles dropped on a concrete floor, yet they remained locked in a tight embrace. He concluded that there must be hidden matter providing the extra gravity, but the scientific community largely ignored his terrifying discovery for decades. Fast forward to the 1970s, and Vera Rubin confirmed the impossible when she watched the stars at the edges of spiral galaxies. Just like a merry-go-round, the outer edges should spin slower than the center. But Rubin saw that they were moving at breakneck speeds. The stars at the edge were moving just as fast as those in the core, a violation of Newtonian physics that sent shivers down the spine of astronomy. Something invisible was adding mass, creating a gravitational halo that extended far beyond the visible light of the galaxy, enveloping us all. We are living inside a massive, invisible sphere, and the visible stars are just speckles of dust floating in a vast ocean of nothingness. Scientists have built massive detectors deep underground, buried in mines, hoping to catch a single particle of this dark matter crashing into a nucleus. They wait in silence, shielded from cosmic rays, praying for a signal that will tell us we are not alone in this room. But the detectors remain silent, and the silence is becoming louder than the theories, suggesting that we might be fundamentally wrong about reality itself. What if dark matter isn't matter at all, but a symptom of a broken theory of gravity that we have clung to for centuries? Imagine if the rules of the universe change depending on where you are, and out in the deep void, gravity behaves like a monster. We are like ants trying to understand the highway system by only looking at the crumbs on the pavement, completely missing the cars speeding by. The bullet cluster collision provided the most violent evidence yet, where gas dragged behind while the invisible mass kept moving forward, unhindered. It was a ghost passing through a wall, proving that this dark substance does not interact with normal matter, or even with itself. This creates a horrifying picture of a universe where the majority of existence is completely indifferent to the light, life, and matter we cherish. We are drifting through a sea of invisible particles that could be passing through your brain right now, completely unfelt and unknown. But recently, the mystery has deepened, with some galaxies appearing to have no dark matter at all, defying every model we have created. How can a ghost be everywhere and nowhere at the same time? The inconsistency suggests we are missing a crucial piece of the puzzle. Some physicists are now whispering about modified Newtonian dynamics, or MOND, a theory that suggests gravity itself is the liar. If MOND is true, there is no dark matter, and our understanding of the fundamental forces of the universe is shattered beyond repair. This would mean Einstein was wrong, Newton was wrong, and we have been navigating the cosmos with a map that does not match the territory. The implications are terrifying because if gravity is different on large scales, then the stability of the universe is not what we thought. We look at the cosmic microwave background, the afterglow of the Big Bang, and it tells us that dark matter must exist to form structure. Without it, the universe would be a smooth, featureless soup of gas with no galaxies, no stars, and certainly no human observers. So we are left with a paradox. The ghost is necessary for our existence, yet it refuses to reveal its face to us. Perhaps dark matter is not particles, but primordial black holes, ancient remnants from the first second of time that clutter the dark. These tiny, invisible monsters could be swarming the galaxy, distorting light and gravity without ever being directly seen by our telescopes. Or maybe, just maybe, gravity is leaking from another dimension, a higher plane of reality that bleeds into our own. String theory suggests that gravitons can move between branes, meaning the missing mass is actually the weight of a parallel universe. We feel the presence of a mirror world, a shadow realm that is close enough to touch but forever separated by the dimensional veil. The idea that we are interacting with a parallel reality is no longer science fiction. It is a serious contender for the truth. Every time you feel the pull of the Earth, you might be feeling the combined weight of two worlds, locked in an eternal gravitational dance. The James Webb Space Telescope is now peering deeper than ever, and what it finds might break physics completely. It is seeing galaxies that formed too early, too big, and too fast, defying the timeline that dark matter models have predicted. The standard model of cosmology is cracking under the pressure of new data, and through the cracks, something unsettling is staring back. As we peel back the layers of the universe, we are realizing that the darkness is not empty. The darkness is alive with unknown forces. To understand the magnitude of the lie we are living in, we have to go back to the 1930s and stand alongside Fritz Zwicky, a man who was as abrasive as he was brilliant. Zwicky was peering deep into the Coma Cluster, a massive gravitationally bound structure containing over 1,000 individual galaxies, located roughly 320 million light-years away from Earth. He wasn't just looking at the pretty lights. He was doing the forensic accounting of the cosmos, tallying up the mass of the stars and comparing it to the speed at which the galaxies were moving. According to the laws of physics established by Newton and refined by Einstein, the amount of visible matter, the stars, the gas, the dust, provided a specific amount of gravitational glue. But when Zwicky clocked the speeds of these galaxies, he found they were moving at thousands of kilometers per second. At that velocity, the cluster should have torn itself apart eons ago. The visible gravity was simply too weak to hold onto them. It was the first crack in the facade of reality, a mathematical proof that the universe contained more than what meets the eye. Zwicky crunched the numbers again and again, utilizing the virial theorem, which relates the average kinetic energy of a system to its potential energy, and the result was always the same, glaringly impossible. The galaxies in the Coma Cluster were moving so fast that they required 400 times more mass than what was visible to keep them gravitationally bound. Think about the terror of that calculation. Imagine holding a handful of sand, but it weighs as much as a mountain. That is what Zwicky was looking at. He called this missing ghost material Dunkel Materie, dark matter. It wasn't just a rounding error or a smudge on the telescope lens. It was a screaming declaration that 99% of the universe at that time appeared to be completely invisible to us. The structural integrity of the cosmos depended on a substance that refused to interact with light, a substance that was effectively a ghost holding the entire skeleton of the universe together. You would think that such a discovery would revolutionize science overnight, sending astronomers scrambling to their observatories to find this invisible glue, but you would be wrong. The scientific community largely ignored Zwicky, dismissing his Dunkel Materie as a miscalculation or an overestimation of the distance to the cluster. For decades, the idea lay dormant, treated as a curiosity or an error by a man known for calling his colleagues spherical bastards, because they were bastards no matter which way you looked at them. Humanity went on believing that what we saw was what we got, that the protons, neutrons, and electrons that make up our bodies were the primary actors on the cosmic stage. We were arrogant in our blindness, content to study the lit room while ignoring the vast, terrifying dark house that surrounded it. It took another 40 years for the evidence to become so overwhelming that it could no longer be swept under the rug of academic pride. Enter Vera Rubin in the 1970s, a time when technology had finally caught up to the mystery, allowing us to peer not just at clusters but at the internal mechanics of individual spiral galaxies like Andromeda. Rubin wasn't looking for a fight, she was looking for a quiet problem to solve, studying the rotation curves of galaxies. In our own solar system, the rules are simple and intuitive. The planets closer to the Sun, like Mercury, move incredibly fast to counter the strong gravitational pull, while planets further out, like Neptune, orbit lazily in the dark. This is Keplerian decline, and every physicist on Earth expected galaxies to behave the same way. The dense core of stars in the center should whip around furiously, while the sparse stars on the galactic edges should drift slowly through the void. It was a prediction based on centuries of verified gravitational theory. But when Rubin developed the spectra and plotted the data points on her graph, the line didn't drop. It stayed terrifyingly flat. The stars at the very edge of the galaxy, tens of thousands of light years from the core, were moving at the same breakneck speed as those in the center. In any sensible universe governed by the visible distribution of mass, those outer stars should have been flung out into intergalactic space like water spinning off a bicycle wheel. The fact that they remained locked in orbit meant only one thing. There was a massive amount of invisible matter extending far beyond the visible disk of the galaxy. This wasn't just a localized anomaly in the Coma cluster anymore. This was everywhere. Every spiral galaxy was spinning too fast to survive, implying that every single galaxy we see is merely a brightly lit decoration embedded in a much larger invisible structure. We realized then that galaxies are not flat disks floating in space. They are spheres. We are living inside a massive, invisible bubble, a dark matter halo, that envelops the Milky Way and extends hundreds of thousands of light years into the void. This halo is the only reason our sun hasn't been ejected into the darkness. It provides the extra gravitational grip required to hold this high-speed carousel together. The visible galaxy, everything we have ever known or seen, is just a bit of baryonic dust that fell into the center of a gravity well created by this dark leviathan. We are the afterthought. The primary structure of the universe is dark matter, and we are just the bioluminescent moss growing on the back of a whale, completely unaware of the beast that carries us through the ocean. Faced with this existential crisis, the standard model of particle physics tried to fight back with a theory that seemed almost too perfect, the WIMP, or weakly interacting massive particle. The theory proposed that these particles were forged in the intense heat of the Big Bang, just like normal matter, but they lack the ability to interact with the electromagnetic force. They don't reflect light, they don't absorb light, and they don't emit light. They simply exist, carrying mass and exerting gravity. It was a comforting thought because it brought the unknown back into the realm of the known. If dark matter is just a particle, we can catch it, we can build a trap. We can study it. It turned the cosmic horror into a mere engineering challenge, and scientists convinced themselves that discovery was imminent, just a few years and a few $1 million away. So humanity began the Great Hunt. We dug deep into the earth, kilometers beneath the surface in places like the Homestake Mine in South Dakota and the Gran Sasso Mountain in Italy, building cathedrals of science designed to listen to the silence. Experiments like LUX and XENON-1T utilized massive tanks of liquid xenon, cooled to cryogenic temperatures, shielded from cosmic rays, and watched by thousands of sensitive photomultiplier tubes. The idea was simple. Eventually, purely by chance, a dark matter particle flying through the Earth should crash into a xenon nucleus, creating a tiny flash of light. We built the most sensitive ears in the history of our species, capable of hearing a pin drop across a continent, and we waited for the universe to whisper its secrets to us. But the universe remained silent. Year after year, the detectors ran, collecting terabytes of data, filtering out background radiation, looking for that one golden event that would confirm the existence of the WIMP. And year after year, the result was a deafening zero. We ruled out the heavy WIMPs, then the light WIMPs, then the supersymmetric partners. The parameter space, the map of where these particles could possibly hide, began to shrink rapidly. The miracle of the WIMP theory started to look less like a miracle and more like a mirage. We have spent billions of dollars and decades of human intellect chasing a ghost that refuses to manifest, leading some brave souls to ask the forbidden question: what if the particle isn't there? What if we have built a trap for an animal that doesn't exist? We are now approaching the neutrino floor, a limit where the background noise from solar neutrinos becomes so loud that it will drown out any potential dark matter signal, rendering our current technology useless. If we don't find it soon, we may never find it using these methods. The silence from the underground labs is becoming a data point in itself. It suggests that our fundamental assumption that dark matter is a particle similar to the ones we know might be the greatest error in the history of physics. We are standing at a crossroads where we must decide whether to keep digging deeper into the same hole or to accept that the map we are using is fundamentally wrong. The failure to detect WIMPs is not just a disappointment. It is a crisis that threatens to unravel the standard model of particle physics. However, the believers in dark matter have a weapon, a smoking gun that they point to whenever doubters arise: the bullet cluster. This is a crime scene where two massive clusters of galaxies smashed into each other at millions of miles per hour. It is one of the most violent events in the universe, and it provided a unique opportunity to separate the visible matter from the invisible. When these clusters collided, the hot gas, which makes up most of the normal matter, slammed into each other and slowed down, creating a drag effect. But the galaxies themselves, and the dark matter purported to surround them, should have passed right through each other like ghosts. And that is exactly what we saw. Using gravitational lensing, where the gravity of a massive object bends the light from background stars, astronomers were able to map where the mass was located in the bullet cluster. The result was shocking. The majority of the mass was not where the hot, glowing gas was. It was ahead of the collision, moving with the galaxies. The visible matter had been stripped away, but the invisible gravity kept going. To the mainstream community, this was the nail in the coffin for alternative theories. It proved that stuff was there, separate from the gas, separate from the atoms. It proved that dark matter interacts with gravity, but ignores the electromagnetic forces that cause friction. It was the ghost caught on camera, walking through a wall. Based on this, we built computer simulations of the entire universe, like the Millennium simulation, which programmed the laws of dark matter into a supercomputer and let it run for 13 billion years. The results were hauntingly beautiful. The simulation showed that dark matter forms a cosmic web, a vast, intricate scaffolding of invisible filaments that stretch across the universe. These filaments act as the highways of the cosmos, guiding gas and dust into their intersections, where they pool together to form galaxies. According to this model, every star you see, every galaxy in the Hubble Deep Field, is merely a decoration hanging on this invisible Christmas tree. Without the dark matter web, the universe would be a diffuse, structureless fog. This creates a picture of reality where we are subservient to the dark. The formation of the Milky Way, the formation of the Sun, and the formation of the Earth were all dictated by the gravitational collapse of this invisible substance. We exist only because the dark matter allowed us to. It accumulated the gas, it shielded the proto-galaxies, and it held the structures together against the expansion of the universe. We are living in a guest house built by a landlord we cannot see, cannot touch, and cannot communicate with. The success of these simulations in matching the large-scale structure of the universe is the strongest fortress for the dark matter theory. It works on the big screen. It explains the web. But when you zoom in, the picture starts to glitch. The simulations that work so perfectly on the scale of billions of light years start to fail miserably when we look at individual galaxies. This is known as the cusp core problem. The computer models predict that dark matter should pile up in the center of galaxies, creating a sharp, dense cusp of invisible mass. But when we look at real galaxies, especially dwarf galaxies, we don't see this cusp. We see a core, a flat, uniform distribution of mass in the center. The theory predicts a mountain, but observation reveals a plateau. This isn't a small discrepancy. It's a fundamental disagreement between the simulation and reality, suggesting that dark matter doesn't behave the way we think it does when things get crowded. Then there is the missing satellites problem. The dark matter simulations predict that a galaxy the size of the Milky Way should be swarming with thousands of tiny satellite dwarf galaxies, trapped in our gravitational halo like bees around a hive. But when we look up, we only see a handful, about 50 or 60. Where are the thousands of others? Are they there, but completely dark, made entirely of invisible matter with no stars to light them up? Or is the theory wrong? Are we predicting ghosts that simply aren't there? This absence of small galaxies is a gaping hole in the theory, a silence where there should be a chorus of cosmic companions. We have to ask ourselves a difficult question. Have we invented a phlogiston for the modern age? In the 18th century, scientists believed a substance called phlogiston existed to explain fire. It didn't exist. It was a placeholder for oxygen, which they hadn't discovered yet. Is dark matter our phlogiston? We have named our ignorance, quantified it, and put it in textbooks, but naming a mystery doesn't solve it. The term dark matter gives a false sense of security, implying we know it is matter, and we know it is dark. But reality might be far stranger. It is possible that we are trying to fix a broken equation by adding an imaginary variable, rather than admitting the equation itself is flawed. This brings us to the heretics, the physicists who dare to suggest that there is no invisible matter, but rather a misunderstanding of gravity itself. In the early 1980s, an Israeli physicist named Mordechai Milgram proposed a radical idea called MOND, Modified Newtonian Dynamics. Milgram looked at the data and said, what if Newton was wrong? What if the laws of gravity are not universal? What if, when gravity becomes incredibly weak, like at the edges of a galaxy, it doesn't fade away as quickly as Newton predicted? It was a simple tweak to the math, changing the formula for gravity at extremely low accelerations, but the consequences were monumental. MOND introduces a new constant of nature, a threshold called a naught. Below this acceleration threshold, gravity switches gears and becomes stronger than expected. If you apply this simple rule to the galaxies that Vera Rubin studied, the need for dark matter vanishes instantly. The rotation curves flatten out naturally, not because of a halo of invisible ghosts, but because gravity itself behaves differently in the deep void. It explains the motion of the stars perfectly without adding a single gram of invisible mass. It is a terrifyingly elegant solution because it implies that for 300 years, we have been using a law of gravity that only applies to the strong fields of our solar system, completely misunderstanding the weak fields of the cosmos. Proposing MOND is like walking into the Vatican and declaring that God is a metaphor. It is scientific blasphemy. It challenges general relativity, the crown jewel of physics. If MOND is right, Einstein's curvature of spacetime is at best incomplete and at worst a special case of a deeper, stranger theory. The scientific community fought back hard, labeling MOND as a curve-fitting exercise, a mathematical trick with no physical basis. But MOND refuses to die. It keeps predicting phenomena that dark matter fails to explain. It has become the zombie theory that rises from the grave every time a dark matter detector comes up empty. One of the most bizarre predictions of MOND is the external field effect, which states that the internal dynamics of a galaxy can be affected by the gravity of other galaxies millions of light years away. In standard Newtonian physics, if you are in a falling elevator, you don't feel the gravity outside. This is the strong equivalence principle, but MOND violates this. It says that a galaxy in a crowded cluster should spin differently than an isolated galaxy, even if the internal mass is the same. It implies a universe that is interconnected in ways we cannot perceive, where the motion of a star here is subtly dictated by the presence of a galaxy far, far away. Recently, astronomers tested this by looking at wide binaries, pairs of stars that orbit each other at great distances, where gravity is incredibly weak. This is a natural laboratory to test MOND on a smaller scale. The results were controversial but startling. The stars were moving faster than Newton's laws allowed, exactly as MOND predicted. If these results hold up, it is the first direct evidence that gravity is broken at low accelerations. It would mean that dark matter is an illusion, a shadow cast by our incorrect math, and the universe is actually much lighter, much emptier, and much stranger than we ever imagined. The war between dark matter and modified gravity is a battle for the soul of physics. On one side, you have the invisible universe, populated by ghostly particles we cannot catch. On the other side, you have the modified reality, where the fundamental laws of nature are fluid and changeable. Both options are terrifying in their own way. Either we are surrounded by invisible monsters, or we do not understand the basic rules of the game we are playing. And as the data comes in, the The line between these two theories is beginning to blur, leading some to propose a third, even more exotic option. What if dark matter is a superfluid, a state of matter where atoms lose their individual identity and flow together without friction, like a single giant quantum wave? This theory proposes that the vacuum of space is not empty, but filled with a cosmic ocean of this superfluid. In this model, galaxies are like vortices, swirling in a frictionless sea. When the fluid is calm, it behaves like dark matter. When it is disturbed, it generates phonons, sound waves, that mediate a force looking exactly like MOND. It attempts to unite the two warring factions, suggesting that the universe is a quantum phenomenon on a macroscopic scale. This is the concept of a Bose-Einstein condensate, usually created in labs at temperatures near absolute zero, but now applied to the entire cosmos. If this is true, we are literally swimming in a quantum soup. The reason we don't feel it is because we are made of normal matter that floats through it. But this superfluid supports the galaxies, carries the vibrations of gravity, and defines the geometry of space. It transforms the cold, dead vacuum into a living, shivering entity that reacts to the movement of stars. It evokes a feeling of cosmic horror, that space itself is a substance, thick and pervasive, and we are trapped within it like insects in amber. Imagine the implications. If the universe is a superfluid, then what we perceive as gravity might just be the pressure and buoyancy of this medium. Ripples in this fluid could carry information or energy across vast distances instantly, defying our understanding of light speed limits. It paints a picture of a universe that is far more interconnected and fluid than the rigid vacuum of Einstein. We are not separated by nothingness. We are connected by a medium we cannot perceive, a medium that might have its own currents, its own tides, and its own storms that we mistake for cosmic anomalies. Then there is the return of an old nightmare: primordial black holes. Before the first star ever ignited, in the chaotic density of the first second after the Big Bang, some patches of space might have been so dense that they collapsed directly into black holes. Stephen Hawking proposed this decades ago. These wouldn't be the massive monsters we see today, but tiny, silent killers ranging from the size of an atom to the mass of the moon. If the universe is swarming with these ancient remnants, they could account for all the missing mass without requiring a new particle. For years we dismissed this idea, thinking we would have seen them by now. But when LIGO, the Laser Interferometer Gravitational Wave Observatory, turned on, it started hearing things that shouldn't exist. It detected black holes crashing into each other that were far heavier than what stellar evolution predicts. Where did these massive black holes come from? The possibility arose that LIGO is not just hearing star deaths, it is hearing the dark matter itself. If dark matter is actually a swarm of black holes, then we are detecting the sound of them feeding on each other in the dark. This hypothesis transforms the dark matter halo from a cloud of particles into a swarm of deadly singularities. Imagine our galaxy filled with millions of invisible gravitational traps wandering through the solar systems. If one were to pass through our solar system, it would disrupt the orbits of the planets, perhaps flinging Earth into the sun or out into the void, and we wouldn't see it coming until the gravity hit us. It turns the galaxy into a minefield, where death is invisible and instant, a remnant of the violent birth of the cosmos waiting to reclaim us. There is even a theory that the elusive Planet 9, the hypothetical planet perturbing the orbits of objects in the outer Kuiper belt, might not be a planet at all. It could be a primordial black hole, roughly the size of a grapefruit, but with 5 times the mass of Earth, orbiting our sun. If this is true, we have a piece of dark matter right in our backyard, a tiny monster captured by our star eons ago. We have been looking for a planet reflecting sunlight, but we should be looking for a distortion of the background stars, a tiny lens of gravity circling in the deep freeze of the outer system. And we cannot forget the axion, the light contender. While WIMPs are heavy, axions are hypothetically billions of times lighter than an electron. They are so light that they behave more like waves than particles. The axion was invented to solve a completely different problem in quantum chromodynamics, the strong CP problem. But physicists realized it could also be the missing matter. If axions exist, they are everywhere, streaming through us in the trillions every second. We would be wading through a sea of axions so dense it constitutes the majority of the mass in the room, yet we feel nothing. The strong CP problem is a deep crack in the standard model regarding why the neutron doesn't have an electric dipole moment. It sounds technical, but the symmetry of the universe depends on it. The axion is the cleaning lady of physics, sweeping up this mess. If it exists, it solves two of the biggest mysteries in science at once: why nature respects certain symmetries and what holds the galaxies together. It is the perfect candidate, almost too perfect, which makes the silence of the axion detectors just as unnerving as the silence of the WIMP detectors. To catch an axion, we use a different kind of trap: a haloscope. The theory predicts that in the presence of a super strong magnetic field, an axion can spontaneously convert into a photon, a particle of light. So we build massive magnetic chambers, like the ADMX experiment, and listen for a radio signal appearing out of nowhere. We are literally trying to turn the ghost into a ghost light. It's a seance conducted with superconducting magnets and quantum amplifiers, trying to coax the invisible into the visible spectrum. The ADMX team scans through frequencies slowly, like turning the dial on a radio, hoping to tune into the station of the dark matter. But the frequency range is vast, and the axion could be anywhere. It is a search for a needle in a haystack where the needle is invisible and the haystack is infinite. Every time they finish a scan and find nothing, they mark that frequency as ruled out and move on. It is a slow, grinding process of elimination that has been going on for years, with no song heard on the radio yet. The nightmare scenario for particle physics is that dark matter exists, but it interacts only through gravity. If that is true, we will never detect it in a lab. We will never catch a WIMP or an axion. We will never have a piece of it in a jar. We will simply have to watch the galaxies spin and accept that there is a shadow world we can never touch. It would mean the end of experimental particle physics as a tool for discovery in this realm. We would be forever separated from the truth by a wall of non-interaction, destined to observe the effects but never the cause. This leads to the concept of the dark sector. Why should dark matter be just one particle? Visible matter is complex. We have quarks, leptons, bosons, forming atoms, molecules, stars, and people. Why should the dark side be simple? It is entirely possible that there is a whole periodic table of dark matter. Dark protons, dark electrons, dark photons. A mirror universe with its own chemistry, its own forces, and perhaps its own complexity. If there is dark chemistry, then particles could bind together to form dark atoms. These atoms could clump into dense clouds, forming dark stars or dark planets that drift through our galaxy unseen. They wouldn't emit light, but they would have gravity. We could be passing through a dark solar system right now. There could be a shadow Earth occupying the same space as our Earth, but made of material that passes through us like we are ghosts. The complexity of the dark sector is a terrifying thought because it mirrors our own, suggesting we are not the unique inhabitants of this space. Speculating further, if there are dark stars and dark planets, could there be dark life? Beings evolved from complex dark chemistry, living in the shadow universe, looking at their own dark sky, wondering about the missing mass, which is actually us. It sounds like science fiction, but physics does not forbid it. If the interactions allow for complexity, then evolution, or something like it, could take hold in the dark sector. We could be sharing the universe with an entire ecosystem that we are physically incapable of perceiving. This is the ultimate cosmic humility. The anthropomorphic principle usually places us at the center of observation, but the dark matter problem shoves us into the corner. We are the minority. The baryonic matter, the stuff of stars and skin, is just 5% of the energy budget of the universe. Dark matter is 27%, and dark energy is 68%. We are the foam on the ocean. Imagining we are the tide, we are the anomaly. The universe is primarily dark, and we are just a rare, glowing contamination in a vast, invisible machine. The mystery is accelerating, quite literally, with the new data from the James Webb Space Telescope. We expected JWST to peer back to the dawn of time and see tiny, messy baby galaxies slowly assembling their dark matter halos. That was the prediction of the standard model. But what JWST saw made astronomers gasp. It saw massive, fully formed, bright galaxies existing just a few 100 million years after the Big Bang. These universe breakers are too big, too bright, and too old to exist that early in the timeline. According to the standard dark matter model, known as lambda CDM, gravity needs time to pull the dark matter together into wells deep enough to trap gas and form stars. It's a slow, bottom-up process. But these high redshift galaxies suggest a process that was explosive and rapid. It's as if we looked at a nursery and found teenagers with full beards. The timeline doesn't fit. The structures were already there, massive and imposing, when the universe was in its infancy. This suggests that either the Big Bang happened earlier than we think, or our understanding of how structure forms, and thus dark matter, is fundamentally flawed. Interestingly, MOND proponents predicted this. In a modified gravity universe, the collapse of gas clouds happens much faster because you don't have to wait for the dark matter to settle. The stronger gravity at the get-go pulls material together violently. The existence of these impossible early galaxies is a feather in the cap of the heretics and a black eye for the standard model. It is yet another piece of data that whispers, "You are wrong about the darkness." And then there is the Hubble tension. We have two ways to measure how fast the universe is expanding. One is by looking at the cosmic microwave background, the baby picture of the universe, and projecting forward using our dark matter model. The other is by looking at nearby supernovas and measuring the distance directly. The problem is, the two numbers don't match. They differ by about 10%, a gap known as 5 sigma, which in physics means this is not a statistical fluke. The universe is expanding faster than our dark matter theories say it should. This tension suggests that something is pulling the universe apart, or something acted in the early universe that we haven't accounted for. Is it early dark energy? Is it decaying dark matter? Or is it that our understanding of gravity is failing again? The fact that our best map of the cosmos cannot agree on the basic speed limit of expansion is a sign of a crumbling paradigm. We are trying to force a square peg into a round hole, and the peg is the size of the universe. Some theorists propose early dark energy, a field that existed briefly after the Big Bang, spiked the expansion rate and then vanished, leaving only its ghostly footprint on the data. It feels like adding epicycles to the planetary orbits, a complex fix to save a dying theory. We are adding more and more invisible entities, dark matter, dark energy, early dark energy, just to make the math work. At what point do we stop adding ghosts and start questioning the house we are haunting? We are currently in a crisis of cosmology comparable to the late 19th century. Back then, scientists believed in the luminiferous ether, an invisible substance that was supposed to carry light waves. They searched for it, they built experiments to detect it, and they found nothing. It turned out the ether didn't exist. Einstein showed us that space itself was the medium. We might be in the exact same position today. Dark matter might be the ether of the 21st century. A fiction we invented because we couldn't comprehend the true nature of space-time. The transition from the ether to relativity was painful. It required abandoning intuition and accepting a universe where time dilates and space curves. The transition away from dark matter, if it happens, will be equally traumatic. It will mean abandoning the safety of the particle zoo and venturing into the wild territories of modified gravity, higher dimensions, or quantum geometry. It will mean admitting that for 50 years we have been chasing a phantom of our own making. But until that revolution comes, we are stuck in the uncomfortable middle. We have observations we cannot explain and a theory that cannot be detected. We are like detectives at a crime scene, where the body is missing, the weapon is missing, but the floor is covered in blood. We know something happened. We know the gravity is there, but the perpetrator remains elusive, mocking our attempts to categorize it. The universe is under no obligation to make sense to us, and right now, it is exercising that right with vengeance. The psychological horror of dark matter isn't just about the science. It's about the feeling of isolation. It reinforces the idea that we are strangers in a strange land. If the dominant material of the universe is something we cannot touch, see, or interact with, then we are not truly of this universe. We are visitors, trapped in a bubble of light, surrounded by an ocean of dark water that goes down forever. It makes the cosmos feel colder, more alien, and more indifferent to our existence than we ever dared to fear. So where do we go from here? We are now turning to even stranger ideas, like self-interacting dark matter, SIDM. This theory suggests that while dark matter ignores us, it talks to itself. It proposes that dark particles collide and scatter off one another, redistributing heat and energy within the dark halos. This could solve the cusp core problem by smoothing out the centers of galaxies. It's a compromise. It keeps the particle, but gives it a social life. But even this is a guess, a tweak to the parameters to fit the uncomfortable data. The truth is, we are throwing darts in the dark, hoping to hit a target we cannot see. As we peel back the layers of the cosmic onion, we encounter the cosmological principle, the golden rule of astronomy, which states that the universe is homogeneous and isotropic, meaning it looks the same in every direction, and the laws of physics are uniform everywhere. It is the bedrock upon which all our dark matter calculations rest. But recently, a terrifying anomaly known as the cosmic dipole has threatened to shatter this assumption. When we measure the temperature of the universe, one side of the sky is distinctly hotter than the other. We are told this is because our galaxy is moving at a tremendous speed towards a massive gravitational attractor. But the speed required to explain this dipole is suspicious. We are moving too fast, pulled by something too big, something that our maps of dark matter density simply cannot account for. It feels as though the entire universe is tilted, sliding downhill towards a drain we cannot see. This gravitational anomaly leads us to the Great Attractor, a region of space that is pulling the Milky Way and thousands of other galaxies towards it with terrifying force. For years, we thought dark matter explained this mass, but as we peer through the zone of avoidance, the dust-clogged center of our own galaxy blocking the view, we are finding that the mass isn't sufficient. The Great Attractor is just a prelude to the Shapley supercluster, an even larger monster behind it. We are being dragged across the universe by a chain of gravitational giants, and the standard dark matter models fail to predict the sheer scale of this flow. It implies that the distribution of matter in the universe is not smooth but lumpy and violent, and we are caught in a current that is sweeping us away into the unknown. The anomalies don't stop at the edge of the universe. They are right here in our neighborhood, screaming that our model is broken. This is the plane of satellites problem. According to the cold dark matter theory, dwarf galaxies should swarm around a host galaxy like the Milky Way in a random, chaotic beehive pattern. They should be buzzing in all directions, driven by the random accretion of dark matter clumps. But when we look at the Milky Way, and recently at Centaurus A, we see something that shouldn't happen. The dwarf galaxies are aligned. They are orbiting in a thin, flat plane, marching in lockstep like soldiers on parade. The odds of this happening by chance in a dark matter universe are less than 1 in 1,000. It suggests that these galaxies weren't formed by random dark matter clumps, but by a structured, coherent process that our simulations completely miss. This alignment of satellite galaxies is a dagger in the heart of the standard model because it implies tidal dwarf galaxies, galaxies formed from the debris of a massive collision between larger galaxies. If these dwarfs are formed from debris, they shouldn't have dark matter in them at all, because the dark matter doesn't interact to clump together in the debris tail. Yet, these galaxies appear to have mass discrepancies. If they have no dark matter but still spin too fast, then the only conclusion is that MOND, or modified gravity, is correct. The plane of satellites is a structure that defies the invisible ghost. It suggests that gravity is stronger than we think, and the ghost was never there to begin with. We are looking at a coherent clockwork mechanism, not a chaotic swarm, and physics hates coincidences. If gravity is the culprit, we must consider the radical and unsettling theory of emergent gravity, proposed by physicist Eric Verlinde. This idea strips gravity of its status as a fundamental force of nature. Instead, Verlinde argues that gravity is an emergent phenomenon. Like heat. Heat isn't a particle. It's the statistical result of vibrating atoms. Similarly, gravity might be the result of the entropy of the universe trying to maximize itself. In this view, space-time is not a physical stage, but a byproduct of information processing. When mass moves, it changes the information content of the vacuum, and the resistance to that change is what we feel as gravity. It's a concept that turns the universe into a thermodynamic machine, cold and indifferent, where what we call falling is just the universe trying to scramble its data more efficiently. In Verlinde's emerging gravity, dark matter is an illusion caused by the elasticity of space itself. At large scales, the entropy of the vacuum contributes an extra force, masquerading as invisible mass. It predicts the rotation of galaxies without needing a single particle of WIMPs or axions. It implies that our hunt for dark matter particles is as futile as hunting for heat particles or sound particles. We are trying to catch a statistical effect in a bottle. If Verlind is right, reality is much more like a hologram or a simulation than a physical object. The excess gravity is just a glitch in the code, a rounding error that manifests when we look at the very large, low-acceleration regions of the cosmos. The holographic principle ties into this, suggesting that all the information in the universe is encoded on a 2D surface at the boundary of the cosmos, and we are just the 3D projection of that data. If dark matter is a symptom of this holographic entanglement, then we are literally living in a projection. The darkness is the memory of the system. This philosophical horror suggests that we are not solid, independent entities, but rather pixelated expressions of a distant information horizon. The solidity of the Earth beneath your feet is a lie. It is maintained by the informational pressure of the universe. When we look for dark matter, we are essentially trying to see the pixels of the screen we are projected upon. But let's step back to the particle world, where the desperation has led to the resurrection of the sterile neutrino. We know neutrinos exist. They are ghost particles that pass through light years of lead without stopping, but they are too light to be dark matter. However, theory allows for a heavier cousin, the sterile neutrino. This particle would be even more ghostly than the regular neutrino, interacting only via gravity. It wouldn't feel the weak nuclear force. It would be a ghost of a ghost. If they exist, they were produced in the Big Bang and have been decaying very, very slowly ever since. They fit the data, they fit the models, but they are defined by their absolute refusal to be detected by standard means. They are the ultimate introverts of the particle zoo. Astronomers thought they found the sterile neutrino in 2014 when they detected a mysterious spike in X-ray emissions from galaxy clusters, known as the 3.5 keV line. It was a specific wavelength of X-ray light that couldn't be explained by known atomic transitions. Excitement rippled through the community. Was this the faint signal of sterile neutrinos decaying into photons? It was the whisper in the dark we had been waiting for. Telescopes were pointed, data was crunched, and papers were written. It seemed like the answer was finally within our grasp, a specific energy signature that revealed the hidden mass of the universe. The ghost had finally spoken. But the universe is cruel. Subsequent observations with better resolution, specifically from the Hitomi satellite before it tragically spun out of control, failed to see the line clearly. Some analyses suggested it was just a boring signal from potassium or chlorine atoms in the hot gas, mundane elements masquerading as cosmic mysteries. The signal fades in and out of the noise depending on who analyzes the data, becoming a phantom of statistics. The 3.5 keV line has become a symbol of the look elsewhere effect, the danger of staring at static until you see a face. We are so desperate to find dark matter that we might be hallucinating patterns in the random noise of the cosmos. If particles fail us, we turn to waves. Enter fuzzy dark matter. In quantum mechanics, every particle is also a wave. For normal particles, the wavelength is tiny. But if dark matter is an incredibly light boson, billions of times lighter than an electron, its wavelength could be light years long. This means the particle is fuzzy, smeared out over galactic scales. In this theory, dark matter isn't made of distinct bullets. It's a giant, overlapping quantum field that behaves like a superfluid Bose-Einstein condensate on the scale of the entire galaxy. The galaxy is not filled with particles. It is filled with a single, humongous quantum wave function. This fuzzy theory solves the cusp core problem beautifully. Because of the Heisenberg uncertainty principle, you cannot pack these large waves too tightly together. They resist being squeezed into the center of the galaxy, naturally creating the flat core we observe instead of the dense cusp predicted by WIMPs. It creates a solitonic core, a stable, standing wave of dark matter in the heart of the Milky Way. We might be living inside a giant quantum soliton, a stable pulse of energy that has persisted for 13 billion years. It blurs the line between matter and geometry, suggesting the galaxy is held together by a quantum hum. Yet, even with these exotic theories, we slam into the too-big-to-fail problem. Our simulations of cold dark matter predict that there should be massive, dense sub-halos of dark matter orbiting the Milky Way. These halos are so big that they should have inevitably pulled in gas and started star formation. They should be bright, obvious dwarf galaxies. But they aren't there. We see empty space where our theory says there should be massive satellites. Unless they are there, but they are completely dark. Dark galaxies. Clumps of invisible matter that failed to ignite a single star. Invisible leviathans swimming silently through our backyard, undetectable until we crash into them. Astrophysicists try to patch this hole with baryonic feedback. They argue that when the first stars formed in these halos, they went supernova and blew all the gas out, shutting down further star formation and leaving the halo invisible. It's a violent, chaotic solution. The universe destroys its own nurseries. But does it work? Or is it a fine-tuned excuse? It requires the explosions to be exactly strong enough to wipe out the visible galaxy but leave the dark halo intact. It feels like we are forcing the puzzle pieces together with a hammer, bending the laws of star formation to save the theory of dark matter from extinction. This creates a feeling of unease known as epicyclic reasoning. In the Middle Ages, when astronomers thought the Earth was the center of the universe, they invented complex loops, epicycles, to explain the backward motion of planets. They made the math work, but the premise was wrong. Our baryonic feedback, biased star formation, and dark sectors are modern epicycles. Are we adding complexity to a model that is fundamentally broken at its core? The history of science tells us that when a theory requires this many patches to survive, it is usually about to collapse. The revolution is coming, and it will be merciless to our current understanding. Let's descend into the dark sector again, but deeper. Consider the dark photon. In our world, the photon carries the electromagnetic force, light, heat, radio waves. If dark matter has its own complex interactions, it must have its own force carrier, the dark photon. This particle would act like light for dark matter, allowing dark particles to cool down and clump together. But here is the horror. Dark photons could theoretically mix with regular photons. A tiny fraction of them could bleed into our universe. This means there is a shadow light passing through the room right now, a spectrum of radiation that our eyes and cameras are completely blind to, carrying information we cannot access. If dark electromagnetism exists, it allows for the existence of mirror matter. This is the idea that for every particle in the standard model, there is a dark mirror version. Dark protons, dark electrons, dark hydrogen. This isn't just a cloud of dust. This is the building block for mirror stars and mirror planets. These objects would be invisible to us, detectable only by their gravity. A mirror star could drift through our solar system, invisible to the eye. But its gravity would wreak havoc on the asteroid belt, sending comets raining down on Earth. We would see the apocalypse coming, but we would never see the cause. The collision of the Milky Way and Andromeda is inevitable. In 4 billion years, our galaxies will merge. But the dark merger has already begun. The massive dark matter halos of our two galaxies extend far beyond the visible stars, and they are likely already touching, mixing, and interacting. The friction between these dark halos will determine the fate of the merger. If dark matter interacts with itself, the halos will slow each other down, merging quickly. If it doesn't, they will pass through each other, oscillating for eons. We are the passengers in a car crash that is happening in slow motion, driven by the physics of the invisible. One of the most terrifying possibilities for dark matter is macroscopic dark matter, or macros. Instead of tiny particles, what if dark matter is made of dense nuggets of nuclear material, ranging from the size of a cricket ball to a boulder? These objects would have the density of an atomic nucleus. If one of these macros hit the Earth, it wouldn't just stop. It would punch a hole straight through the planet, exiting the other side like a bullet through an apple. The energy release would look like a nuclear explosion or a massive earthquake with no epicenter. Some scientists have actually looked for the seismic signature of such an event. They have analyzed millions of earthquake records, looking for a linear track of disturbances that would indicate a macro passing through the Earth's core. While they haven't found a smoking gun yet, The fact that we have to check our own planet for bullet holes from invisible cosmic snipers is a testament to how little we know. We are unprotected, shielded only by the vast probabilities of space, waiting for the dark bullet that has our name on it. Could the Tunguska event of 1908 have been a dark matter impact? A massive explosion flattened 2,000 square kilometers of Siberian forest, but no crater was ever found. No meteorite fragment. Just devastation. While the leading theory is an airburst meteor, some papers suggest it fits the profile of a small primordial black hole or a chunk of antimatter or dark matter passing through the atmosphere. It brings the cosmic mystery down to the ground level. Sometimes the sky falls and it leaves no trace of what hit us, only the silence of destruction. We must also consider the gravitino, the hypothetical superpartner of the graviton in supersymmetry theory. The graviton carries gravity. The gravitino is its heavy, dark twin. If supersymmetry is real, the Big Bang should have produced oceans of gravitinos. But supersymmetry is currently on life support. The Large Hadron Collider, LHC, has smashed protons together for years, hunting for these sparticles, and found absolutely nothing. The failure to find SUSY particles is a catastrophe for string theory, and for the most elegant explanations of dark matter. The universe is refusing to be elegant. It is messy, broken, and devoid of the symmetries we desperately want to exist. This leads to the nightmare scenario of particle physics, that the energy scale of new physics is simply out of our reach. We might need a collider the size of the solar system to create a dark matter particle. We are like cavemen banging rocks together, trying to understand nuclear fusion. If the dark matter particle is too heavy, we will never ever produce it in a lab. We will be forever locked out of the engine room of the universe, left only to stare at the dials on the dashboard, gravity and expansion, without ever being able to pop the hood. It is a permanent limit to human knowledge. But the alternative, modified gravity, has its own monsters. One such theory is MOG, Modified Gravity, by John Moffat. It posits that gravity is not just one field, but a combination of tensor, vector, and scalar fields. It adds a, quote, fifth force, a repulsive force that counteracts gravity at short ranges but fades away at long ranges. This complex interplay can mimic dark matter perfectly, but it requires rewriting general relativity, the most successful theory in history. It suggests that Einstein's masterpiece is just an approximation, a low-resolution JPEG of a high-resolution reality we haven't seen yet. The strongest fortress for dark matter has always been the cosmic microwave background, CMB. The patterns of hot and cold spots in the afterglow of the Big Bang match the dark matter prediction with chilling precision. Specifically, the acoustic peaks, sound waves from the early universe, seem to require dark matter to dampen them. Mond has struggled to explain this. For years, this was the checkmate. But recently, a relativistic version of Mond called Skordis-Zaloznik theory has managed to reproduce the CMB peaks without dark matter. The wall is cracking. Even the baby picture of the universe might be interpreted differently if you change the lens. Let's talk about the KBC void. Several studies suggest that the Milky Way is located in a massive underdensity of the universe, a bubble that is relatively empty compared to the cosmic average. This void is roughly 2 billion light-years across. If we live in a hole, it skews all our measurements. The expansion rate inside the hole would look faster than the outside, creating the Hubble tension illusion. It means our local reality is not a fair sample of the universe. We are living in the boondocks, the deserted wasteland of the cosmos, assuming that the city looks just like the desert. This local void hypothesis makes the dark matter problem even slipperier. If our density measurements are wrong, our gravity estimates are wrong. We might be overestimating the need for dark matter simply because we underestimate the emptiness around us. We are fish in a bowl, unaware of the refraction of the glass, calculating the size of the room based on distorted light. The universe might be far more heterogeneous than the smooth, safe models of the textbooks. It is a jagged, broken landscape, and we are in a deep valley, unable to see the peaks. Then there is the unsettling question of dark matter heating. If dark matter passes through planets, does it heat them up? Even if the interaction is weak, the sheer flux of particles over billions of years could deposit energy into the core of the Earth or Jupiter. Some scientists have proposed that we look at old neutron stars. These dead stars should be cold. But if they are sitting in a dark matter halo, they might be capturing particles which annihilate in their core, keeping them unnaturally warm. A warm neutron star would be a beacon in the dark, a lantern fueled by the invisible. Could dark matter be carcinogenic? It sounds like a conspiracy theory, but it's a valid question in biophysics. If WIMPs interact with atomic nuclei and one of them strikes a DNA molecule in your body, it could break the chain. The probability is infinitesimally low, far lower than background radiation, but it is non-zero. If dark matter is denser in certain parts of the galaxy, could there be dead zones where life is impossible because the dark radiation shreds genetic material? We might be protected not just by our atmosphere, but by our location in a sparse region of the dark halo. The intersection of dark matter and black holes offers another twist: black hole hair. Classical physics says black holes have no hair. They only have mass, spin, and charge. But if dark matter interacts in complex ways, it could form a hair or a wig around the black hole, a structure that extends out and modifies the event horizon. This would change the gravitational waves we detect when they merge. LIGO might eventually hear the scream of the dark matter being ripped apart as it falls into the singularity, a specific frequency that reveals the nature of the beast. Now, we must face the dark energy connection. We treat dark matter, clumping, and dark energy, pushing apart, as separate mysteries. But what if they are two sides of the same coin? This is the dark fluid theory. It proposes a single substance that acts like matter when it is dense, holding galaxies together, and acts like energy when it is sparse, pushing the universe apart. It unites the two great unknowns into a single, terrifying field that dictates the entire evolution of the cosmos. We are bobbing in a fluid that can crush us or tear us apart, depending on its mood. If dark energy is dynamic, we face the big rip. If the density of dark energy increases over time, phantom energy, it will eventually overcome gravity, then electromagnetic forces, then nuclear forces. First, it will rip the galaxies apart. Then, it will tear the solar systems apart. Then, it will rip the Earth apart. Finally, a fraction of a second before the end, it will rip your atoms apart. The universe ends not in a whimper, but in the violent shredding of every structure that ever existed. Dark matter is the only thing fighting against this, the only thing holding the line. The Chaplygin gas model is a specific mathematical formulation of this unified dark fluid. It describes a universe that transitions from a dust-dominated past to an accelerated expansion future smoothly. But the implications are strange. It suggests that the sound speed of the vacuum could become imaginary, leading to instabilities where the vacuum itself could decay. We are walking on thin ice, and the ice is made of a substance we haven't even identified yet. There is also the information paradox of dark matter. If black holes destroy information, a contentious point, and dark matter is made of primordial black holes, then a huge percentage of the universe's history is being actively deleted. The universe is a hard drive that is slowly corrupting its own files. Every time a particle falls into a primordial black hole, its quantum state is erased from the observable universe. We are losing the past, bit by bit, into the maw of the dark sector. Let's consider the great filter of knowledge. Perhaps there is a limit to what a conscious species can understand about the cosmos. Maybe dark matter isn't a puzzle to be solved, but a wall, a cognitive horizon. Just as a dog cannot understand calculus, maybe we biologically cannot understand the true nature of 95% of the universe. Our brains evolved to hunt and gather on the African savanna, not to comprehend 11-dimensional M-theory or non-baryonic superfluid dynamics. The horror is not that the answer is scary, but that the answer is incomprehensible. The XENON-1T detector recently reported an excess of events, more flashes than expected. For a brief moment, the world held its breath. Was it dark matter? Solar axions? Or was it just tritium, a tiny amount of radioactive hydrogen contaminating the detector? The most likely answer is tritium. It is a cruel joke. The universe dangles a tantalizing clue in front of us, and it turns out to be dirty equipment. This cycle of hope and disappointment is exhausting the scientific community, leading to a crisis of faith in the scientific method itself regarding the dark sector. But what if the excess was solar axions? If the sun is producing axions, it changes our understanding of stellar evolution. It means stars cool down faster than we thought, bleeding energy into the dark sector. It would age the universe differently. It would mean every star is a portal, leaking energy into a parallel reality. The sun on your face feels warm, but it might be ghosting half its power into a dimension you will never see. We are approaching the era of gravitational wave astronomy as our primary tool. We are building LISA, a space-based detector that will listen to the low-frequency hum of the universe. It might hear the background noise of the Big Bang itself. If dark matter was created in a violent phase transition in the early universe, LISA will hear the echoes. It will be like listening to the recording of the birth of the ghosts. We are hoping the audio track of the universe reveals what the video track has hidden. The concept of vacuum decay is the ultimate sword of Damocles. If the Higgs field, which gives particles mass, is not in its most stable state, a quantum fluctuation could trigger a bubble of true vacuum. This bubble would expand at the speed of light, rewriting the laws of physics, destroying all matter, all dark matter, and all life instantly. Some theories suggest that the stability of the vacuum depends on the exact nature of dark matter. If dark matter is of a certain type, it might stabilize the Higgs. If it's another, it might be pushing us toward the edge. We are balancing on a knife edge we cannot see. As we look at the cosmic web, the filaments of dark matter connecting the galaxies, we realize they look suspiciously like neurons. The large-scale structure of the universe resembles a brain cell. This is the panpsychism hypothesis taken to the extreme. Is the dark matter web a neural network? Is the universe thinking? It sounds insane, but the mathematical resemblance between the growth of cosmic structure and the growth of biological neural networks is statistically significant. If the dark matter is the gray matter of the universe, then we are just insignificant molecules flowing through the bloodstream of a god. This biological analogy reinforces the Gaia hypothesis on a galactic scale. The galaxy behaves like an organism. It regulates its star formation, it breathes gas in and out, and it maintains its structure using the skeleton of dark matter. If we remove the skeleton, the organism dies. We are part of a living system that operates on timescales of billions of years, a system that is largely invisible to us. We are the microbiome of the Milky Way, unaware of the host's true nature. In the end, the WIMP miracle has turned into the WIMP nightmare. We bet the house on one horse, and it hasn't crossed the finish line. We are now scrambling to cover our bets, looking at everything from black holes to superfluids to modified gravity. The textbooks are being rewritten in real time. The certainty of the late 20th century has evaporated. We are back in the Wild West of physics, where the sheriff is missing and the laws are negotiable. But this chaos is where the thrill lies. If dark matter turns out to be wrong, it will be the greatest discovery since Copernicus. It will liberate us from the invisible cage. It will mean gravity is something new. It will mean Einstein was the beginning, not the end. The destruction of a theory is violent, but it clears the forest for new growth. We are standing with matches in hand, ready to burn down the standard model if that's what it takes to find the truth. The cosmic variance problem reminds us that we only have one universe to study. We cannot run experiments by creating 1,000 universes and seeing which ones have dark matter. We have a sample size of 1. This is the fundamental limit of cosmology. We are trying to deduce the laws of probability from a single event. It is like trying to determine if a coin is fair by flipping it once. The fact that we exist at all might be the biggest statistical outlier of them all. We are trapped in the observability horizon. There are regions of the universe that are retreating from us faster than the speed of light. We will never see them. They are lost to the darkness forever. If the answers to dark matter lie in those distant regions, we will never know. The universe is erasing its own evidence as it expands. We are racing against time to solve the mystery before the clues fly away into the eternal void. The sheer scale of the unknown is humbling. 95% of the universe is dark matter and dark energy. 5% is us. We are the rounding error. We are the dust on the lens. To claim we understand the universe because we understand atoms is like claiming to understand the ocean because we understand a cup of water. The deep ocean is dark, crushed by pressure, and filled with monsters. That is the reality of the cosmos. Perhaps the most disturbing thought is that dark matter is non-local. In quantum mechanics, particles can be entangled across vast distances. What if dark matter is the physical manifestation of this entanglement? What if it is the glue that connects every point in space to every other point? It would mean that space is not a vacuum, but a solid block of connection, and we are just moving through the cracks. We look at the void galaxy concept again, galaxies that exist alone in the great voids. They seem to produce stars at a different rate. They are the hermits of the cosmos. If Mond is right, these galaxies should behave very differently from those in clusters due to the external field effect. Studying these lonely outposts might be our best chance to break the deadlock. They are the control group in the great experiment of the universe. As we move forward, we must be willing to accept post-empirical science. String theory and the multiverse might never be testable. Dark matter might never be directly detected. We might have to accept theories based on their mathematical beauty rather than experimental proof. This is a dangerous path. It leads back to religion, to belief without evidence. But the universe might leave us no choice. The hunt continues. We are building bigger colliders, more sensitive detectors, and launching telescopes to the far side of the moon. We are not giving up, but the shadow is long, and the night is deep. As we stare into the abyss of the missing mass, we must remember, the abyss is also staring into us, and it is heavy, silent, and overwhelmingly dark. The cracks in the foundation of physics are getting wider, and they are appearing in places we thought were secure. Take the muon G2 experiment at Fermilab. We shot muons, heavy cousins of electrons, around a magnetic ring to measure how much they wobble. The Standard Model, the most successful theory in human history, predicted a specific wobble with extreme precision. But the muons didn't obey. They wobbled too much. They were interacting with something in the vacuum that wasn't in our books. This tiny wobble is a scream in the quiet room of physics. It suggests that the vacuum is seething with unknown particles or forces, perhaps the dark matter particles we have been hunting, or perhaps something even stranger. It is the first tangible proof that the Standard Model is bleeding, and whatever is causing the wound is invisible, pervasive, and currently rewriting the laws of reality as we know them. Following closely on the heels of the muon anomaly is the W boson mass crisis. The CDF collaboration recently announced that the W boson, a fundamental particle carrying the weak nuclear force, is significantly heavier than the Standard Model allows. It is as if you weighed a liter of water and found it weighed 2 kilograms. It breaks the mathematical symmetry of the universe. If the W boson is too heavy, then the Higgs mechanism, the very thing that gives the universe mass, might be more complex than we thought. This extra mass has to come from somewhere. Is it interacting with the dark sector? Is the Higgs field we know just one layer of a multi-layered reality? If the fundamental weights and measures of the universe are wrong, then our calculation of the missing mass of dark matter might be based on a scale that was broken from the start. These particle anomalies feed into the hierarchy problem. Why is gravity so incredibly weak compared to the other forces? A simple fridge magnet can overcome the gravity of the entire Earth to pick up a paperclip. This weakness is suspicious. It suggests that gravity is leaking out of our 3 dimensions into a higher dimensional bulk. This is the brain world hypothesis. Imagine our universe is a sheet of paper floating in a room. The other forces are stuck to the paper, but gravity can travel through the air. If this is true, dark matter might just be the shadow of matter on a parallel sheet, a parallel universe, hovering just millimeters away from us in a 4th spatial dimension. We can't see them, but we feel their gravity pulling on our stars. We are effectively haunted by the neighbors next door. The psychological toll of these failures on the scientific community cannot be overstated. For 40 years, thousands of brilliant minds have dedicated their lives to supersymmetry, SUSY, the elegant theory that promised to solve everything and provide the dark matter particle. But the Large Hadron Collider has turned SUSY into a graveyard. We have smashed particles at energies that recreate the conditions of the early universe, and we have found nothing. No superpartners, no neutralinos. Just the Standard Model, holding on for dear life. This great silence from the collider is forcing physicists to confront the possibility that the universe is not elegant. It might be a messy, chaotic accident, with no unifying symmetry. The death of Susie leaves us without a map, wandering in a dark forest where the old rules of navigation no longer apply. Let's consider the dark forest theory, usually applied to aliens, but here applied to dark matter. What if dark matter is self-organizing? Some complexity theorists suggest that given 13.8 billion years, dark matter could have evolved its own structures, its own dark life. If so, why haven't we seen it? Maybe it is hiding. But a more terrifying thought is that dark matter is the remains of a previous structure. What if the universe is a graveyard of dead civilizations that converted their matter into a more stable, invisible form to escape the heat death? This is wild speculation, but in the absence of data, the mind wanders to the extremes. We see 85% of the matter is dark. Maybe that's the final state of all matter, a cold, invisible tombstone marking where light once shone. The Kardashev scale classifies civilizations by their energy use. A Type 3 civilization controls a galaxy. If such a civilization existed, they might enclose stars in Dyson spheres to harvest energy. A star in a Dyson sphere would vanish from visible light but still have gravity. It would look exactly like dark matter. Could the missing mass be a sign of industrial activity on a galactic scale? Are we looking at a galaxy that has been colonized and shrouded? While the distribution of dark matter, the halo, doesn't perfectly fit this technological explanation, the Dyson swarm hypothesis for certain anomalies remains a haunting possibility. We might be mistaking the city lights of a galactic empire for the background noise of the universe. We have found galaxies that are almost entirely made of dark matter, like Dragonfly 44. This galaxy is as massive as the Milky Way, but has only a fraction of the stars. It is a ghost galaxy, a dark cloud held together by immense gravity with barely any lights to show for it. How does nature form a galaxy with 99.9% dark matter? It defies the standard model of star formation. It sits in the coma cluster like a silent sentinel. Is it a failed galaxy? A galaxy that lost its gas? Or is it a clump of pure dark matter that managed to steal a few stars as decoration? Dragonfly 44 is a reminder that the normal galaxies like ours might be the exception, and the dark, silent ones are the rule. Conversely, we found NGC 1052 DF2, the galaxy with no dark matter. This discovery was weaponized by both sides. Dark matter proponents said, "See, dark matter is a substance because you can have a galaxy without it. It's separable." Mond proponents scrambled to explain it with the external field effect. But the existence of this galaxy is deeply unsettling. It's a transparent galaxy, a fragile collection of stars that shouldn't survive in the violent gravitational tides of the cluster, yet there it is. It proves that the relationship between visible matter and dark matter is not a fixed ratio. It is chaotic, random, and unpredictable. The universe is playing dice with the fundamental ingredients of galaxies. This chaos brings us to the fine-tuning problem. The amount of dark matter in the early universe had to be precisely set to allow for the formation of galaxies. If there was too little, the universe would be a diffuse gas. If there was too much, everything would have collapsed into black holes. The value sits on a razor's edge. Why? Is it luck? Or is it the anthropic principle that we are here to observe it only because we are in the one universe out of a trillion that got the recipe right? This implies a multiverse, a frothing sea of failed universes where the dark matter ratio was wrong. And those universes are cold, dead, and empty. We are the survivors of a cosmic lottery we didn't know we were playing. The axis of evil is a pattern found in the cosmic microwave background that shouldn't exist. The hot and cold spots in the afterglow of the Big Bang seem to be aligned with the plane of our own solar system. This is impossible. The Big Bang happened 13.8 billion years ago. Our solar system is 4.5 billion years old. There should be no connection, yet the data shows an alignment. Is it a calibration error, or is the universe smaller than we think? Some topologies, like a toroidal universe, a donut shape, could create these repeating patterns. If the universe wraps around itself, then dark matter might be the gravitational ghost of our own galaxy pulling on us from the other side of the loop. We might be feeling the weight of our own echo. Topology offers a strange escape from dark matter. If the universe is not flat but has a complex shape, like a Poincaré dodecahedral space, then light would take different paths to reach us, creating illusions of multiple images and distorted gravity. We assume light travels in straight lines, but in a curved universe, straight is relative. We might be looking at a hall of mirrors. The missing mass could be a geometric illusion caused by the folding of space itself. We are trying to measure the volume of a room without realizing the walls are curved and the ceiling is the floor. The geometry of the cosmos might be the true monster hiding in the dark. Let's look at the vacuum energy problem, the worst prediction in physics. Quantum field theory predicts that the vacuum of space should be bursting with energy, 10 to the power of 120 times more energy than we observe. This is the cosmological constant. If this energy were real, the universe would have ripped itself apart in a nanosecond. But it didn't. Why is the vacuum energy so close to zero, but not zero? Dark energy is the tiny remnant of this calculation. Some theories suggest that dark matter and dark energy are coupled, that the dark matter is eating the vacuum energy to grow. We are living in a universe that is balancing a cancellation of forces so precise that it defies all logic. The Casimir effect proves that empty space isn't empty. Two metal plates placed close together in a vacuum will be pushed together by the quantum foam outside them. This is real, measurable pressure from the virtual particles popping in and out of existence. If this quantum foam has mass, it contributes to the gravity of the universe. We are floating in a sea of virtual ghosts. Dark matter might be the gravitational weight of these virtual particles. It means that nothingness weighs something. The void is heavy. The more empty space you have, the more it weighs. It flips our intuition on its head. The emptiness is the heaviest thing in the universe. At the smallest scales, we hit the Planck length, the pixel size of the universe. Below this, physics as we know it dissolves. Space and time cease to have meaning. Some theorists propose that dark matter lives in the cracks of space-time, in the granularity of the vacuum. If space is made of discrete chunks, like sand, rather than a smooth sheet, then particles could get trapped in the gaps. These defects in the fabric of reality would have mass but no charge. We would be walking over a rug that is full of dust, and the dust is the dark matter. We can't see it because it is woven into the weave of existence itself. String theory offers a landscape of 10 to the power of 500 possible universes, the string landscape. Most of these solutions are unstable, but recently, the swampland conjecture suggested that our universe, with its dark energy and dark matter, might actually be in the swampland, meaning it is theoretically impossible or unstable in string theory. This is a crisis. It implies that our best theory of everything says our universe shouldn't exist. Are we a simulation? Are we a temporary fluctuation that is about to pop? If physics says you shouldn't be here, and we are here, then physics is missing a massive piece of the puzzle, likely hidden in the dark sector. We are searching for primordial gravitational waves, ripples from the Big Bang itself. These waves would imprint a specific twisting pattern, called B-modes, on the polarization of the cosmic microwave background. Finding these B-modes would be the smoking gun for inflation, the rapid expansion of the early universe. But dust, interstellar dust, mimics this signal perfectly. In 2014, the BICEP 2 team announced a discovery, only to realize later it was just dust in our own galaxy. The dark matter we see might be another form of this cosmic dust, a foreground fog that we are mistaking for background structure. The universe is dirty, and looking through the grime is leading us to false conclusions. There is a phenomenon called cosmic birefringence. It suggests that the universe might have a preferred direction, twisting the polarization of light as it travels billions of years. If true, this violates parity symmetry, the idea that the universe looks the same in a mirror. A twisting universe suggests that dark matter or dark energy is a chiral field, like a corkscrew. It means space itself has a handedness. We are moving through a left-handed or right-handed vacuum. This exotic physics could explain why matter won over antimatter and why the dark sector dominates. We are in a twisted reality, literally. The Hubble bubble hypothesis returns to the idea that we are in a void. If our local region of the universe is less dense than the average, matter would flow away from us towards the denser regions. This outflow mimics dark energy. But what if the density is just dark matter? If we are in a dark matter desert, and the rest of the universe is a dark matter ocean, we would see the galaxies receding faster than expected. We are the isolated tribe in the desert, unaware of the thriving cities over the horizon, inventing dark energy to explain why nobody visits us. Our galaxy, the Milky Way, is not stationary. We are moving at 600 kilometers per second relative to the cosmic background. We are falling towards the Great Attractor, which is falling towards the Shapley supercluster. But recent maps show a dipole repeller, a region of space behind us that is pushing us away. This void is so empty that it effectively exerts a repulsive force. It's a dark void. We are being pushed by nothing and pulled by the invisible. The dynamics of the local universe are dominated by these dark structures, vast regions of emptiness, and vast mountains of invisible mass that dictate our fate. We have mapped our local supercluster and named it Laniakea, which means immeasurable heaven in Hawaiian. It is a structure of 100,000 galaxies, all flowing along gravitational rivers towards a central valley. But Laniakea is just one node in the cosmic web. The filaments of dark matter that define Laniakea are stretching and thinning as the universe expands. Eventually, the filaments will snap. Laniakea will dissolve. We will be cut off from the rest of the supercluster. Dark energy is winning the war against dark matter. The web is breaking. We are witnessing the slow disintegration of the largest structures in existence. The cold spot in the CMB is a massive region of the sky that is significantly colder than it should be. It is a bruise on the face of the universe. Some theorists suggest it is the imprint of a collision with another universe, a bubble collision. If we live in an eternal inflation multiverse, universes are constantly popping into existence like bubbles in a soda. Occasionally they bump into each other. The cold spot might be the scar where a parallel reality rubbed against ours, draining energy or depositing dark matter. It is a window into the multiverse, a terrifying hint that we are just one bubble in a cosmic foam. This leads to the Boltzmann brain paradox. In an eternal universe filled with random fluctuations and dark matter, it is statistically more likely for a fully formed brain to hallucinate this reality than for the entire universe to evolve naturally. If the universe lasts forever, the freak observers will vastly outnumber the biological observers. Are you a biological entity with a past, or are you a Boltzmann brain that materialized a second ago with false memories? The dark matter problem exacerbates this because it adds more mass and more entropy to the system, increasing the odds of these nightmares. Physics tells us we shouldn't exist, which is the most terrifying fact of all. Entropy is the arrow of time. Things go from order to disorder. But dark matter seems to be the scaffolding that allows order to arise. It clumps together, forming wells for galaxies. It fights entropy. But ultimately, entropy wins. The heat death is inevitable. Dark matter particles will eventually decay or fall into black holes. The black holes will evaporate via Hawking radiation. The universe will become a sea of photons, cooling towards absolute zero. The Big Freeze. Dark matter is just the temporary dam holding back the flood of nothingness. We are living in the brief, shining moment before the eternal dark. Is there retrocausality in the dark sector? In quantum mechanics, the future can influence the past in certain experiments. If dark matter operates on quantum rules at galactic scales, could the future state of the universe be dictating the formation of galaxies today? This is the block universe concept, that the past, present, and future exist simultaneously. We are just crawling through it. Dark matter might be the structure of the 4D block, the rigid lattice of time that is already written. We are not moving through empty space. We are moving through a frozen crystal of time, and dark matter is the glass. The neural network analogy keeps coming back because the math is too similar to ignore. The cosmic web grows exactly like a biological brain or a fungal network. The wood wide web of mycelium connects trees in a forest. The cosmic web connects galaxies in the universe. Is dark matter the mycelium? Is it a transport network? If information travels along these filaments, then the universe is a processing unit. The computation of the universe is happening in the dark sector. We are just the glowing output pixels on this screen. The real work is happening in the wires, in the dark. Speed of information is the limit. Light takes billions of years to cross the web. but non-locality in quantum physics suggests instant connection. If dark matter is a Bose-Einstein condensate, it could support non-local interactions. The entire galaxy could react as a single unit instantly. This would explain why the spiral arms hold together. It's not gravity traveling at light speed, it's a quantum state that is shared globally. The galaxy is a single quantum object, a single atom the size of 100,000 light-years. We are living inside a giant atom. Quantum Darwinism suggests that the reality we see is the one that survived the selection process of information copying. The stable states replicate. Dark matter provides the stability. It is the environment that selects the survivors. Without dark matter, the universe would be too volatile for stable information, life to exist. So in a sense, dark matter is the selector, the gardener that decided we should exist. It pruned the universe of unstable timelines and left us with this one. Roger Penrose proposes conformal cyclic cosmology, CCC. He believes the universe goes through infinite cycles of big bangs, eons. At the end of a universe, mass fades away and scale becomes meaningless, leading to a new Big Bang. Penrose claims to see Hawking points in the CMB, scars from supermassive black holes of the previous universe. If this is true, dark matter might be the residue of the previous eon. We are walking through the ashes of a dead universe that came before us. The missing mass is the ghost of the past, literally. Evidence for CCC is controversial, but the idea of the eternal return is ancient and terrifying. It means we have done this before. We will do it again. The dark matter mystery will be solved, then forgotten, then solved again, forever. It makes our struggle for understanding seem both heroic and futile. We are Sisyphus, pushing the rock of knowledge up the hill of a dark matter halo, only to watch it roll back down at the end of time. The technological desperation to find an answer is leading to plans for the Future Circular Collider, FCC, a machine 3 times the size of the LHC. It will cost billions and take decades to build. It is a cathedral to curiosity. But there is a fear. What if we build it, and we still find nothing? What if the energy desert stretches on forever? We might be reaching the limits of what a biological species can build. We might be hitting the technological ceiling of our civilization before we solve the mystery of the dark. Some physicists are turning to tabletop experiments using levitated nanospheres and atom interferometers to test gravity at tiny scales. If we can prove that gravity is quantum, we bridge the gap between Einstein and quantum mechanics. If we find that gravity behaves differently at the micron scale, it could unravel the dark matter knot without needing a collider. The answer might not be in the stars, but in a vacuum chamber the size of a shoebox, watching a speck of dust float in a laser beam. The black hole information paradox is still unsolved. Stephen Hawking admitted he might be wrong about information loss. If information is preserved, where does it go? Does it get encoded on the surface of the black hole? Or does it leak out into the dark sector? Perhaps dark matter is the library of the universe, storing the information of everything that falls into darkness. It is the cosmic hard drive. The mass is just the physical weight of the data. We are surrounded by the archives of the dead. We must address the crisis of cosmology not just as a data problem, but as a paradigm problem. Thomas Kuhn described paradigm shifts occurring when anomalies pile up. The anomalies are piling up. The Hubble tension, the satellite planes, the JWST galaxies, the lack of WIMPs. We are in the pre-revolutionary phase. The old guard is holding on to dark matter because it works for the big picture, but the rebels are finding cracks in the details. A new Newton or Einstein is waiting in the wings, ready to show us that the universe is completely different from what we thought. What if the new physics is not particles or fields, but information, it from bit? The idea that the universe is fundamentally made of yes-no questions. Dark matter might be inactive code, lines of programming that are commented out but still take up memory. We are running on a bloated operating system. The missing mass is just the inefficiency of the cosmic simulation. It explains why it doesn't interact. It's not compiled. It's just there, taking up space. The great filter might also be the dark matter trap. Civilizations might discover the power of the dark sector, perhaps tapping into zero-point energy or vacuum energy, and destroy themselves. The silence of the universe might be because the moment you understand dark matter, you gain the power to unravel space-time. We are toddlers playing with a loaded gun. The fact that we haven't found it yet might be the only reason we are still alive. Let's consider the mirror neutron experiment. Neutrons in a bottle decay at a different rate than neutrons in a beam. The difference is seconds. It's a huge discrepancy. One explanation is that neutrons are oscillating into mirror neutrons, becoming dark matter for a few seconds before turning back. If this is happening, then matter is not stable. The atoms in your body are constantly flirting with the dark side, popping in and out of our reality. You are partially made of ghosts. The cosmic variance limits us. We look at the CMB and see patterns, but we can't look at it from another angle. We are locked in one perspective. Dark matter might be an artifact of our position. If we moved 1 billion light-years to the left, maybe the illusion would vanish. We are victims of our own geography. The universe might be simple, but our view is obstructed by the pillars of our own galaxy and the dust of our own ignorance. The Big Snap is another theoretical end of the world involving dark energy. If the fabric of space-time has a limit to how much it can stretch, it might eventually snap like a rubber band. This would release a catastrophic amount of energy, resetting the universe. Dark matter is the weight stretching the band. We are adding tension to the system every second. The snap could happen tomorrow, or in 1 trillion years. Physics gives us no guarantee of tomorrow. The search for magnetic monopoles is also tied to this. These are hypothetical particles with only one magnetic pole. Inflation says they should be diluted, but they should exist. They are heavy, they could be dark matter, we have never seen one. But if one passed through a coil of wire, it would create a specific signal. We have detectors waiting. The universe is full of mythical creatures, monopoles, axions, WIMPs, gravitinos, that we have named but never caught. It is a bestiary of the invisible. The solar system tests of gravity are getting more precise. We track the Cassini probe, the planets, the moon. We look for deviations. So far, Einstein holds up. But the Pioneer anomaly and the flyby anomaly gave us scares. Spacecraft were not moving exactly as predicted. Most were solved as thermal recoil, heat leaking. But it shows how sensitive we are to tiny forces. We are listening for the heartbeat of the universe, and every skip makes us panic. What about dark globular clusters? Globular clusters are balls of ancient stars. Usually they have no dark matter. But if we found one that did, or a dark cluster with no stars, it would change everything. We are scanning the halos of galaxies for these dark clumps. Gravitational lensing is our tool. We watch background stars brighten as a dark object passes in front. We are looking for the invisible man by watching the crowd part around him. The neutrino background is the only thing we can predict with certainty. There is a sea of neutrinos from the Big Bang. They are cooling. If they have mass, they do. They cluster. They are hot dark matter. They move too fast to form galaxies, but they are part of the mix. We are swimming in them. Trillions pass through your eye every second. The universe is a crowded room, but the crowd is ghosts. The lithium problem. The Big Bang Theory predicts how much lithium-7 should be in the universe. We observed 3 times less than predicted. Where did it go? Did dark matter destroy it? Did axions burn it? It is another hole in the standard model. The first 3 minutes of the universe are mostly understood, but the lithium is missing. It's a loose thread that threatens to unravel the whole sweater. The Lyman alpha forest allows us to map gas clouds back in time. We see the shadows of hydrogen gas against distant quasars. This maps the dark matter distribution. The map shows the clumpiness of the universe. If the universe is smoother than predicted, it supports warm dark matter, or interacting dark matter. The forest is telling us a story, but the language is alien. We are translating the shadows of clouds from 10 billion years ago to understand the ground beneath our feet. Entropic gravity suggests gravity as a probability force. Objects move together because it increases the entropy of the vacuum. It's statistical inevitability. If this is true, dark matter is just an artifact of the entropy equation at large distances. It's not stuff, it's math. It's the tendency of the universe to get messier. We are mistaking the mess for matter. The Planck stars hypothesis. Inside a black hole, the collapse might stop due to quantum gravity, forming a Planck star that bounces back. The black hole is actually a bouncing star in extreme slow motion due to time dilation. If primordial black holes are Planck stars, they could be dark matter, and they eventually explode. Fast radio bursts, FRBs, the explosions of dark matter black holes, we see these flashes from across the universe. Are they the death cries of the dark matter particles? Fast radio bursts are a mystery on their own. Millisecond blasts of energy, brighter than a galaxy. Some repeat, some don't. Is it magnetars, aliens, or dark matter annihilation? If DM creates FRBs, then the universe is a minefield of exploding dark stars. We are sailing through a thunderstorm of invisible lightning. The cosmic web is rotating. Recent studies show that filaments of galaxies are spinning, giant corkscrews of matter stretching millions of light years. How do you spin a filament? It requires angular momentum on a scale that defies logic. Unless the dark matter halo is spinning the web, it suggests the universe has a vorticity. It is a whirlpool. We are not just expanding, we are twisting. The void phenomenon. We found a void so big it can't be explained by standard physics. The Boots void, 330 million light-years of nothing. If you were in the center, you wouldn't know other galaxies existed until the invention of powerful telescopes. Is this a region where dark energy won early? Or a region where dark matter was wiped out? It is a hole in the Swiss cheese of the cosmos, and it is growing. As we enter the final phase of our investigation, we must confront the possibility that we are the cargo cult scientists. We build runways, detectors, and wear headphones, radio telescopes, hoping the planes, dark matter, will land. But maybe we don't understand the mechanism of flight. Maybe the universe operates on principles so far removed from our ape brains that we are simply miming science in the face of the ineffable. The dark sector is not just a room we haven't entered. It might be a dimension we cannot perceive. Consider the terrifying concept of the end of cosmology. Because of dark energy, and the dark matter that fights it, the universe is expanding at an accelerating rate. This means that distant galaxies are being pushed away from us faster than the speed of light. They are crossing the cosmic horizon, a point of no return. Once a galaxy crosses that line, its light can never reach us again. It is effectively deleted from our reality. We are losing data every single second. The universe is actively erasing its own history. Imagine a future civilization arising in our galaxy 100 billion years from now. They will look up and see nothing, no other galaxies, no cosmic microwave background. Just the static stars of their own merged Milky Way Andromeda Island. They will conclude, based on all available evidence, that they are the only galaxy in a static, eternal void. They will develop a physics that is completely wrong, because the evidence for the Big Bang has fled beyond the horizon. We are living in a privileged moment where we can still see the truth, but the door is closing. The darkness is not just hiding the mass, it is hiding the future and erasing the past. This leads us to the Big Freeze, the most likely fate of a dark matter-dominated universe. If dark matter holds the galaxies together but dark energy pushes them apart, eventually the supply of gas for new stars will run out. The universe will turn off the lights, one by one. The last red dwarf star will flicker and die in about 100 trillion years. Then, the universe will enter the black hole era. The only things left will be black holes and dark matter. But even black holes are not eternal. They will slowly evaporate via Hawking radiation, bleeding their mass back into the vacuum as weak particles. If dark matter also decays, then ultimately, there will be nothing left but a thin soup of photons and leptons, getting colder and colder, stretching out into infinity. It is a heat death where time loses all meaning because nothing ever happens again. It is the ultimate victory of the void over the something. The silence will be absolute, and it will last forever. However, if the nature of dark energy is phantom energy, where its density increases over time, we face the Big Rip. This is the violent alternative to the freeze. In this scenario, the repulsive force becomes so strong that it overcomes gravity, then electromagnetism, then the strong nuclear force. First, The galaxy clusters are torn apart. Then, the Milky Way is shredded, sending stars flying into the dark. Then, solar systems are ripped asunder. The Earth is torn from the Sun. In the final moments, the phantom energy becomes infinite. The Earth explodes. Then, your molecules are ripped apart. Finally, the very atoms themselves are shredded, and the fabric of space-time is torn into a singularity. It is a crescendo of destruction where the universe commits suicide. Dark matter is the only thing currently holding the structure together against this phantom menace, fighting a losing battle to keep your atoms intact for just a few billion years more. Let's reconsider the multiverse through the lens of dark matter. If our universe is just one bubble in a frothing sea of eternal inflation, then the laws of physics are merely local bylaws. In other bubbles, there might be no dark matter. In those universes, galaxies never formed. The gas simply dissipated into a thin mist. No stars, no planets, no life. In others, there might be too much dark matter, causing the universe to crunch back into a singularity almost immediately. We exist in the Goldilocks bubble, where the ratio of dark matter to dark energy is finely tuned to allow for complexity. This isn't a comforting thought. It suggests that life is a statistical fluke, a rare mold growing on a sandwich in a garbage dump of failed universes. We are the survivors of a cosmic lottery that destroyed trillions of other potential realities, and we are staring into the darkness wondering why we are so lucky. The Fermi paradox, "Where are all the aliens?" might be directly linked to the dark sector. If a civilization advances far enough, they might realize that baryonic matter, the stuff we are made of, is unstable, inefficient, and vulnerable to radiation and entropy. They might upload themselves into the dark sector. If dark matter is complex and stable, it could be the ultimate substrate for computation. Advanced civilizations might go dark, transferring their consciousness into the invisible web of the universe to escape the dangers of the visible world. We might be alone in the visible spectrum because everyone else has moved into the attic of the universe, leaving the noisy, dangerous ground floor to the primitives like us. The silence of the cosmos is not because it's empty, but because the intelligent life is effectively invisible, watching us from the shadows of the dark matter halo. There is also the zoo hypothesis combined with the dark matter halo. What if the dark matter shell around our galaxy is not natural? What if it is a quarantine field, or a barrier erected by a higher intelligence? We see a gravitational anomaly holding us in. They might see a fence keeping us out. We assume the halo is a random cloud of particles, but its distribution is surprisingly smooth and consistent. If the universe is teeming with life, and we are the violent, unstable new species, it would make sense to encase our galaxy in a gravitational dampener, limiting our ability to travel or be seen. We might be the inmates of a galactic prison, staring at the walls, the dark matter, and inventing physics theories to explain why we can't leave. The missing mass is just the thickness of the cell walls. We must address the crisis of the scientific method. Science is built on the idea of falsifiability. You make a theory, you test it, you prove it wrong. But dark matter has become slippery. Every time we don't find it, we just change the parameters. Oh, it must be lighter, it must be heavier, it must interact less. We are moving the goalposts to keep the theory alive. This is dangerously close to pseudoscience. At what point does a theory become a dogma? If we spend another 100 years not finding dark matter, will we still believe in it? Or will we look back at this era as the dark ages of physics, where we believed in invisible ghosts because we couldn't do the math of gravity correctly? The horror is that we might be trapped in a cul-de-sac of our own making, wasting the greatest minds of our generation on a phantom. The cosmic web connects us to the Great Attractor. But what is pulling the Great Attractor? This is the mystery of dark flow. Galaxies are moving in a unified direction that cannot be explained by the mass of the observable universe. They are streaming towards a point beyond the horizon. Some theories suggest they are being pulled by the gravity of another universe that is pressing against ours. This multiverse contact would mean that dark matter is actually the leakage of gravity from a neighbor. Imagine sleeping in a tent and feeling something press against the canvas from the outside. You can't see it, but you can feel its weight. That is dark flow. We are feeling the pressure of a monster standing just outside the fabric of our reality, pulling our entire galaxy cluster towards a rendezvous we cannot prevent. Let's delve into quantum gravity. We have general relativity for the big stuff and quantum mechanics for the small stuff. They hate each other. They refuse to work together mathematically. Dark matter lives right in the divorce settlement. It is large, galactic scale, but supposedly made of particles, quantum scale. Solving dark matter is the key to the theory of everything. If we find the particle, we link the two worlds. If we don't, and gravity is modified, it means Einstein needs a patch. The fact that we haven't solved this in 80 years suggests that the theory of everything might be beyond human comprehension. We might be hitting the cognitive ceiling of our species. We are smart enough to build nukes, but not smart enough to understand the fundamental architecture of the dark. The stochastic gravitational wave background is the hum of the universe. It is the noise of millions of black holes colliding, stars exploding, and perhaps the turbulence of the dark matter fluid. We are just starting to hear it with pulsar timing arrays. By watching the precise ticking of pulsars, we can detect if the space between us and them is stretching and squeezing. If dark matter is clumpy or substructured, it will leave a fingerprint in this noise. We are tuning into the static of the cosmos. If the static has a pattern, it could reveal the dark code. But if the static is truly random, it means the universe is just noise, and our attempts to find meaning in the dark are the hallucinations of a desperate species terrified of the void. Entropic forces suggest that what we call dark matter is just the vacuum-resisting order. The universe wants to be messy, high entropy. Galaxies are ordered, low entropy. The extra gravity is the vacuum pushing back, trying to disperse the order. In this view, we are fighting the universe just by existing. Every star, every planet, every DNA helix is an insult to the entropic nature of the dark. The dark matter effects are the immune response of the cosmos trying to dissolve the structure of the galaxy. We are not supported by the dark, we are being besieged by it. It explains why the outer stars move fast. They are being dragged into the chaos of the intergalactic void by the entropic pressure of nothingness. What if dark matter is self-annihilating? Some models suggest that when two dark matter particles collide, they turn into pure energy, gamma rays. We have seen an excess of gamma rays coming from the center of the Milky Way, the galactic center excess. It looks exactly like a dark matter bonfire, but it also looks like a cluster of pulsars. We can't tell the difference yet. If it is dark matter, it means the halo is slowly burning itself up. It means the gravitational glue holding the galaxy together is evaporating. Over eons, as the dark matter annihilates, the gravity will weaken and the galaxy will slowly unwind, flinging stars into the dark. We are warming our hands by a fire that is consuming the walls of our house. Modified inertia is a flavor of MOND that suggests the change isn't in gravity, but in Newton's second law, F equals ma. What if inertia, the resistance to movement, is not a constant? What if it depends on the background acceleration? This would mean that an object in deep space is easier to push than an object on Earth. It implies that the mass of an object is not an intrinsic property, but a relationship with the universe. You are only as heavy as the universe allows you to be. This Machian principle connects the atoms in your body to the distant stars. If the distant stars disappeared, your inertia might drop, and you would fall apart. We are entangled with the cosmos in the most intimate way possible. The void problem is getting worse. We see fewer galaxies in the voids than our simulations predict. The voids are too empty. This emptiness anomaly suggests that gravity might be repulsive in the absence of matter. This is a radical idea, that nothing pushes something away. If this is true, then dark energy isn't a separate force. It's just the natural behavior of empty space. As the universe expands and creates more empty space, the repulsion grows, accelerating the expansion. It unifies dark matter, attractive, and dark energy, repulsive, into a single theory of density-dependent gravity. But it means the destiny of the universe is defined by the emptiness, not the matter. The holes in the cheese are growing, and they are eating the cheese. Let's return to the primordial black holes, PBH, one last time. If they exist, they are Hawking radiating. The smaller they are, the hotter they are. The very smallest ones would be exploding right now. We look for these explosions and don't see them. This implies that if PBHs are the dark matter, they must be of a specific mass range, the asteroid mass window. Imagine the galaxy filled with invisible asteroids made of crushed space-time. If one hits Earth, it passes through like a hot knife through butter, but its gravity would cause a micro-earthquake. It would trigger a seismic shudder. We might be getting shot full of holes by these black bullets every day, and our seismometers are mistaking it for tectonic settling. The invisible bombardment is constant. The cosmological constant problem is a discrepancy of 120 orders of magnitude. It is the worst prediction in science. We are missing something fundamental about the vacuum. Some physicists suggest vacuum metamorphosis. The vacuum might undergo phase transitions like water freezing to ice. We might be living in a liquid vacuum that is about to freeze, or a frozen one that is about to melt. If the phase changes, the constants of nature change. The speed of light could shift. The strength of gravity could shift. Dark matter might be the slush in the transition. We assume the universe is stable, but we might be skating on a pond that is cracking. The laws of physics we cherish might be temporary weather patterns in a much grander, more volatile climate. The axis of evil alignment of the CMB with our solar system hints at a geocentric universe, which is scientifically absurd. But what if it's an optical illusion caused by a local dark matter lens? If our local cloud of dark matter has a specific shape, it could distort the background of the universe to look aligned with us. We would be looking at the universe through a funhouse mirror. We think we see the cosmos, but we are just seeing the distortion of our own local bubble. We are trapped in a hall of mirrors, analyzing the reflections and thinking they are windows. The objectivity of science is compromised by the invisible medium we are submerged in. Information realism posits that the universe is made of information, not matter. Dark matter is encrypted data. We can see the file size mass, but we can't open the file. Interaction. Why is it encrypted? Who has the key? Is it a read-only file system? If we could decrypt dark matter, we might find the source code of the Big Bang. Or we might find that it's just junk data, the leftover code from the compilation of the universe. The frustration of the physicist is the frustration of the hacker trying to break into a secure server. We are pounding on the firewall of reality, and the firewall is made of gravity. The Great Filter and dark matter. Perhaps the reason we haven't been visited is that interstellar travel is impossible because of the dark matter drag. If a spaceship travels near light speed, does it hit dark matter particles? Even if they don't interact electromagnetically, they have gravity. At relativistic speeds, the dynamical friction of plowing through the dark matter halo might be significant. It acts as a cosmic speed bump. The universe might be designed to keep civilizations isolated. The ether of the 19th century was drag-free. The dark matter of the 21st century might be a swamp that slows down anyone trying to leave their star. We are grounded by the invisible mud of the galaxy. Panpsychism asks if consciousness is a fundamental property of matter. If so, does dark matter have consciousness? It outweighs us 5-1. If consciousness scales with complexity and mass, then the dark consciousness of the universe would be vastly superior to our own. We might be the subconscious thoughts of a dark matter brain. Our wars, our loves, our discoveries might just be the firing of neurons in the dream of a sleeping giant. The universe doesn't just look like a brain, it might act like one. And we are just the transient chemicals flowing through the synapse, unaware of the mind that contains us. The arrow of time points forward because of entropy. But in the dark sector, time might behave differently. If dark matter is a superfluid or a Bose-Einstein condensate, it exists in a quantum state where time can be symmetric. The past and future impinge on each other. Dark time might be cyclical or stagnant. If we interact with it, do we get dragged into its temporal frame? This could explain the dark energy acceleration. We are falling into a future that is pulling us faster than the past is pushing us. We are caught in a temporal riptide, generated by the invisible bulk of the universe. Emergent spacetime, the idea that space itself is built out of quantum entanglement. If you cut the entanglement, space dissolves. Dark matter might be the glue of entanglement. Where there is dark matter, there is more space, more gravity. Where there is none, space is thin. The voids are regions where the entanglement is breaking. The universe is unzipping. Dark energy is the tension of the break. We are witnessing the disintegration of the manifold. We are living on a fabric that is fraying at the seams, and we call the fraying expansion. The shadow biosphere. If dark matter has chemistry, it has biology. There could be shadow bacteria passing through your body right now. They don't eat your atoms, but they might feed on the shadow energy of your biofield. It sounds like ghost stories. But in a universe with a dark sector 5 times larger than the visible sector, the probability of dark life is non-zero. We search for aliens on Mars while ignoring the possibility of aliens in the room. We are biased by light. We only believe in what shines. But the universe is mostly dark, and the dark is likely teeming with things that do not need to shine to exist. The cosmic censorship hypothesis. Singularities, infinite density, must be hidden behind event horizons. Naked singularities are forbidden because they break causality. But if dark matter clumps too densely without collapsing into a black hole, it could create regions of extreme curvature that verge on naked singularities. These dark knots in space-time would be regions where the laws of physics break down completely. If you flew a spaceship into one, you wouldn't just be crushed, you would cease to be part of the causal universe. You would exit the script. The galaxy might be peppered with these trapdoors, invisible and deadly. Quantum Darwinism again. We see the classical world because it is the most robust state. But maybe dark matter is the discard pile of quantum states. The possibilities that didn't become real. The many worlds interpretation says all possibilities happen. Maybe the other worlds have a gravitational weight. Dark matter is the weight of what could have happened, but didn't in our timeline. We are carrying the burden of 1 billion lost futures on our shoulders. The gravity of regret, physically manifest in the rotation of galaxies. The future of the sun. The sun moves through the dark matter halo as it orbits the galaxy. Sometimes it passes through dense clumps. This could trigger dark matter heating in the Earth's core, causing massive volcanism. Mass extinctions on Earth happen periodically. Some scientists link this to the solar system bobbing up and down through the galactic plane, hitting the dark matter disk. The dinosaurs might have been killed not just by an asteroid, but by the invisible matter of the galaxy disturbing the Oort cloud or heating the planet. The dark side of the galaxy is a periodic killer, and we are due for another pass. Vacuum stability. If the Higgs field tunnels to a lower energy state, the bubble of death expands at light speed. What triggers it? High energy events. If dark matter annihilates at high enough energies, it could be the trigger. We are safe for now. But in the early universe, or in the center of the galaxy, the conditions might be ripe. The universe is a metastable bomb, and dark matter is the fuse. We don't know the length of the fuse. We just know it's burning. The doomsday argument. If we are random observers, we are likely to live in the era with the most observers. If humanity creates 1 trillion descendants, we are early. If we go extinct soon, we are average. The dark matter mystery plays into this. If the universe is hostile, dark forest/great filter, then extinction is the norm. The fact that we are confused by 95% of the universe suggests we are a primitive species near the end of our rope, not the beginning of a glorious galactic empire. We are the confused ape staring at the monolith, and the monolith is the night sky. Retrograde causality in MOND. Some versions of modified gravity suggest that the path of a particle is determined by the future distribution of mass. This breaks the arrow of time. It means the structure of the galaxy today is being held up by the structure it will have in 1 billion years. The universe is pulling itself into existence from the future. We are being dragged forward by destiny, not pushed by history. It's a vertigo-inducing thought. The future is real, and it is heavy, and it is shaping us right now. The simulation hypothesis and computational efficiency. In video games, distant mountains are low-resolution meshes to save memory. Dark matter is the low-res mesh of the universe. It provides the gravity, the physics, without the rendering, the light/interaction. We can't see it because the computer isn't bothering to render it. It's an optimization hack. We are characters in a simulation wondering why the background scenery is blurry. It's blurry because it's not meant to be inspected. We are breaking the fourth wall of reality by looking too closely at the compression artifacts. The Copernican principle has been our guide. We are not special. Earth is not the center. The sun is not the center. The galaxy is not the center. Now dark matter tells us matter is not the center. We are not even made of the main stuff, we are the contamination. The mediocrity principle is absolute. We are a rare, fragile, chemically unstable byproduct of a universe built for cold, dark, invisible particles. To think the universe was made for us is the ultimate vanity. The universe was made for the dark. The cosmic horror is that the universe is indifferent. H.P. Lovecraft wrote about colors out of space and invisible monsters. Dark matter is literally that. It is a presence that pervades our homes, our bodies, and our world, yet ignores us completely. It does not care if we live or die. It only cares about gravity. It is the cold, unblinking eye of a god that is blind to light. We scream into the void, and the void does not echo, because the void is full of heavy, silent ghosts. The unreasonable effectiveness of mathematics. Why does math work? It worked for Newton. It worked for Einstein. But for dark matter, the math is failing. We have to add fudge factors, dark matter, dark energy, to make the equations balance. This suggests we have reached the limit of human mathematics. Maybe the universe is not mathematical at its core. Maybe it is chaotic, biological, or linguistic. We are trying to describe a poem with algebra. The disconnect is fundamental. We are using the wrong tool to measure the night. The great attractor pulls us. The dipole repeller pushes us. We are flowing like water down a drain. Where does the drain lead? To the Shapley supercluster. And beyond that, we don't know. The universe is a river, and we are a leaf. We have no control over our course. We are drifting into the dark, pulled by giants we cannot see, towards a destination we will never reach before the sun burns out. The journey is long, involuntary, and ultimately fatal. The omega point. Will the universe expand forever, big freeze, collapse, big crunch, or rip, big rip? It depends on the density of dark matter. We are measuring omega. If omega is exactly 1, the universe is flat. If it's more, it's closed. If less, open. Our measurements say omega is 1.000, within a margin of error. It is suspiciously perfect. Why? Is it a simulation setting? Or is there a feedback mechanism we don't understand? The fate of all existence hangs on the decimal points of a number we can't quite measure. The Hubble tension is not going away. It is the crack in the dam. The early universe, CMB, says one speed. The late universe, supernovae, says another. They cannot be reconciled without new physics. This new physics is the dragon on the map labeled "Here be monsters." It might be decaying dark matter. It might be early dark energy. It might be that time itself flowed differently in the past. We are standing on the precipice of a paradigm shift that will make general relativity look like a rough draft. The dark sector is a mirror of our hubris. We named it dark because we can't see it. But to a creature made of dark matter, we are the dark matter. We are the luminous matter that is rare and interacts strangely. They might be looking at their telescopes, wondering about the missing light in their equations. We are the ghosts in their machine. The universe is symmetrical in its mystery. We are all ghosts to someone. The final theory. String theory says 10 dimensions. Loop quantum gravity says quantized space. E8 lattice says geometric unity. None of them have predicted a dark matter particle that we have found. The theorists are wandering in the desert. The experimentalists are digging empty holes. The public is waiting for an answer. But the universe owes us nothing. It is entirely possible that we will never know. That the dark will remain dark forever. The overview effect changes an astronaut's perspective. Seeing Earth from space makes it look fragile. Seeing the universe from the perspective of dark matter makes reality look fragile. The visible world is a thin veneer, a coat of paint on a crumbling wall. We are clinging to the paint, hoping the wall holds. But the wall is invisible, and we can hear it creaking. The existential dread of cosmology is the realization that the foundation of our house is made of shadows. Techno-signatures. If we find a Dyson sphere, we solve the Fermi paradox. But if we find no Dyson spheres and no dark matter particles and no Mond confirmation, what then? We are left with the null hypothesis. The universe is empty, broken, and unintelligible. The silence becomes a roar. The lack of answers is the answer. We are alone in a room that is too big, too dark, and too heavy for us to understand. But we keep looking. Why? Because the human spirit is defiant. We are the species that looked at the black ocean and built boats. We are the species that looked at the black sky and built rockets. We are now looking at the black matter and building detectors. Even if we don't find it, the act of looking defines us. We are the light bringers in the dark universe. We are the consciousness of the cosmos trying to wake itself up. The James Webb Space Telescope is our current torch. It is peering back to the cosmic dawn. It sees galaxies lighting up the fog. It is challenging the timeline. It is showing us that the universe grew up fast. The dark ages of the universe ended sooner than we thought. Life might have started sooner. The drama of existence is older and deeper than our models predicted. We are late to the party, but we are finally taking pictures. The cosmic neutrino background, a relic of the Big Bang, colder than the CMB. If we could detect it, we would see the universe at 1 second old. We would see the face of the infant cosmos. It might reveal the secrets of dark matter. But the neutrinos are so low energy they pass through the Earth like it's not there. Catching them requires a detector the size of the galaxy. It is a dream for the far future, a dream of seeing the beginning of time. Gravitational waves are the new sense. Sight, hearing, and now, gravity. We can feel the universe shaking. When black holes merge, they ring space like a bell. We are listening to the music of the spheres, and the song is violent. It is a song of crashing giants and ripping space-time. Dark matter affects the propagation of these waves. If we listen closely enough, we might hear the dampening effect of the dark sea. The answer is in the sound of the crash. The future of humanity is tied to this. If we can manipulate dark matter, we unlock the stars. Warp drives, artificial gravity, unlimited energy. It is the magic of the next millennium. If we can't, we are trapped in the solar system forever, prisoners of the rocket equation. The dark matter problem is the lock on the cage. Solving it is the only way out. We are fighting for our freedom from the tyranny of distance. The legacy of Zwicky and Rubin. They saw the invisible. They pointed at the nothing and said something is there. They were ridiculed, then vindicated, then mythologized. They remind us that the majority is not always right, that the anomaly is the truth, that the thing that doesn't fit is the most important thing in the room. We must keep looking for the things that don't fit. The glitches in the matrix are the doors to reality. The theory of nothing. In the end, maybe the universe sums to zero. Positive energy, matter plus negative energy, gravity equals zero. The universe is a quantum fluctuation of nothing that's stuck around. Dark matter is just the balancing term. We are a complicated way of writing zero. It is a nihilistic but beautiful symmetry. We came from nothing, we return to nothing, and in between, we are the dream of the void. The unfinished symphony. Physics is not done. It is not a closed book. It is a ragged manuscript with pages torn out and chapters written in invisible ink. We are the scribes trying to fill in the blanks. Dark matter is the biggest blank page. It mocks us. It challenges us. It invites us to be better, smarter, braver. The mystery is the engine of our progress. Without the dark, we would have no reason to build the light. So next time you look at the night sky, do not look at the stars. Look at the black space between the stars. That is where the reality is. That is where the monsters are. That is where the mass is. The stars are just the foam. The black is the ocean. You are looking into the face of a mystery that makes up 95% of everything you are not. Respect the dark. It is the majority. It is the master. We are just the guests. Dark matter might not be what we think. It might be gravity, it might be ghosts, it might be a simulation error, or it might be something we lack the language to describe. But it is there, watching, pulling, holding the galaxy together with a cold, invisible grip. We are small, we are blind, and we are afraid of the dark. And perhaps we should be, because the dark is looking back.